Okay, good morning 10G1. So I've just done a little video to support you in being able to factorise and solve quadratics. Picked a few examples from the book, picked some examples of some slightly more tricky situations. Let's give it a go. Right, so we've already seen a little bit on how to factorise straightforward quadratics where these are positive, so let's just go through what we need to do when they're negative. In the same way that you did when we had both of these signs as being add signs rather than take away signs, we're going to start by listing pairs of factors for this final part, for this number part of the quadratic. So, factors of negative 14, we've got 1 and negative 14, we've got 2 and negative 7, we've got minus 1 and positive 14, we've got minus 2 and 7. And if we start to have a look at what they add together to make, because that's going to be the coefficient in front of this n term, 1 add minus 14 is minus 13, 2 add minus 7 is minus 5. Okay, so we know it's going to be these. So we can now start to put the brackets back in. So we're going to have n plus 2 and n minus 7. Okay. Just to check that's correct, we can expand those again. So n times n gives us n squared, 2 times n gives us 2n, n times minus 7 gives us minus 7n, 2n take away 7n is our minus 5n, and 2 times negative 7 gives us negative 14, so we know that's correct. Okay, another situation where we've got some negatives. This time we'll notice that we've got a negative here, but this is positive. So we're going to list, we know that the numbers that have gone to make this can't both be positive because we'd have a positive coefficient for this term in n. Okay, so both of these have to be negative. They've multiplied together to make a positive, because a negative multiplied by a negative is a positive, but when we've added them, they've gone to make a negative. Pairs of factors for negative pairs of factors for 25. We could have minus 1 minus 25. We could have minus 5 and minus 5. Okay, it's really easy to look at these. Negative 1 take away 25 is going to be negative 26, but negative 5 and negative 5, we're on the money there. They're going to add together to make negative 10. So that's pretty straightforward. N minus 5, N minus 5. Okay, now we've got a slightly different type of question here, or a slightly different type of expression. These are in the books, but I've just picked one off the top of my head. And it is, I've written it wrong. How disappointing. Yeah. For some reason I've written it as x squared plus 144, whereas it should be x squared take away 144. Okay, when you see a term, an expression like this, where we've got an x squared term and we've got just a pure number term that doesn't involve x or n or anything like that, you know that it's the difference of two squares. Okay, it's a difference of two squares, and that means that x squared is a square number of some sort, and 144 is a square number, okay? And it's the difference between the two. Okay, that's why it's called difference of two squares, and it's formed by, right, we'll start by listing pairs of factors for 144. We could have 1 and one's going to be negative, one's going to be positive. 1 and 144. One's going to be negative, 1 positive, because this term's negative, this minus 144. We've got minus 2 and 72. We've got minus 3 and 48. And so on and so on and so on. I'm not going to list all these out because it'll take ages. But at some point we will get to 12 and negative 12. And they, just like these others, will multiply together to make minus 144. But importantly, when we add them together, we get nothing. Okay, 12 add negative 12 gives us nothing, and that's why there's no x term there. So we've got, I'll factorise and I'll explain why there's no x term. So open up some brackets. So one bracket's going to be x plus 12, the other bracket's going to be x take away 12. Okay. When we expand that, before you simplify, you're going to end up with x squared, then 12x, add 12x, take away 12x for this minus 12 times x, and then take away 144. When you then simplify it, the 12x and the minus 12x cancel each other out, leaving just this x squared and this minus 144. Okay, solving. I'm only going to do one example here. I'll start with this one that we started with. Okay, so this is an expression. I'm going to do it like it was given to us as an equation. So we've got n plus 2, n minus 7 equals 0. Really important to solve that your factorised expression is set equal to 0. When you give it as a question, it'll be set equal to 0, or you will have to set it to 0, which I'm going to cover in a second. At the moment, we've got these two brackets and they multiply together to make 0. That means that either, because these multiply together and make 0, if neither of these were 0, then this couldn't be 0. So one of these, at least one of these, has to be 0. So either n plus 2 is 0, or n minus 7 is 0. So if n plus 2 equals 0, then n must equal minus 2, because minus 2 plus 2 is nothing. And if n minus 7 equals 0, then n must equal 7, because 7 minus 7 equals 0. So n equals 7. There are two solutions for that set of brackets, for that equation. Okay, in a situation where you are not given your expression set up as an equation equal to 0, you need to make it equal to 0. So we've been given this question out of the book. It's E2 question I, and we need to set that equal to 0 before we do anything else. So all we're going to do is take this 36 off of this side. Minus 36, minus 36. Okay, so we're going to end up with x squared plus 8x. 3 take 36 gives us minus 33 equals nothing, because we have 36 take away 36. We can start expanding, factorising that. So 1 minus 33, 3 minus 11, 11 minus 3. I'm going to stop there because 11 take away 3 gives us the 8. They multiply together to make the minus 33. 11 take 3 is the 8. So we're going to have x plus 11, x minus 3 equals 0. Okay, so either x plus 11 equals 0, so x equals minus 11, or x minus 3 equals 0, in which case x equals 3. Okay, I hope that's been helpful. Job done.